So, hello everyone. Again, we are here to discuss another algorithm under uninformed search. So, this algorithm is the depth limited search, and it is a variation of the DFS or the depth first search. The thing in the depth first search that if your node, no, if you're stuck on this leftmost subtree and it seems to be infinite here, there's no way for you to reach your goal state, which is, for example, located here in the right subtree. So that's why, to prevent this scenario, they have introduced the depth limited search. So since this is a variation of your depth first search, you're still using the stock data structure behavior for our frontier, which uses last in, first out, or FIFO. So for this one, we need to introduce what we call level. So we will limit, since it is a depth limited, so we will set a limit, and that's the only thing we will be traversing. So to set the limit, we need to consider the level. So I'll put a line here to denote the level. Let me change the color. Let's use this one. So we'll introduce a level here. So this is level 0. This is level 1, level 2, then level 3. Yeah. So you can make it more appealing. Let's redraw. No. So I'll use colors to represent. So this will be level 1. This will be, yeah, level 2. Then this will be level 3. And then lastly here is level 4. So for if you have more nodes, then you have other levels. So I'll just rewrite again everything here as a guide. So L0, L1, L2, L3. So let's proceed. So if you're going to perform a depth limited search, you introduce a depth limit here. So depth limit, for example, our depth limit is 3. We will do the DFS. However, it is only on level 3. Let's make it 2 so that because it's on level 3, basically you're considering everything. So make sure let's have only 2. So basically you are already conditioned and up to this level. So again, you're using stack. Concept of stack is default. Last in, first out. So of course, we'll start again with S0 or S rather. And then if you call our node, we need to check the adjacent and then insert it in our stack or frontier. So XYZ, I still follow again the left to right order. X will be inserted. So again, if you're using stack, the behavior insertion will be coming from this end. So X will be inserted first, followed by Y, followed by Z. Then next iteration, we will be calling Z here. So Z will be called. Then let's check. So Z will have the following children, T, U, and V. So rewrite the remaining nodes from the previous frontier and insert T, U, V. So T, U, V will be inserted. T, U, and then we pop again or remove V. So V have W here as child. So if we call V, we need to insert W. So rewrite all the remaining nodes and insert W. And since W is the not doesn't have any children, so W will be called. Then you just U T Y X. So U doesn't have children. So basically, if you remove U, nothing will be inserted. So you can safely rewrite T, Y, and X. And then if you call T on this one, you can see that T have these two children. However, you're only considering that limit 2. So basically, you're cutting your search tree up to here only. And with that, T doesn't contain any children because the children of T is already in level 3. However, you're only considering level 2. So basically, you won't consider it. So it will be just nothing to be inserted. So you just rewrite again X, Y, and X. And then you just continue. You call Y. So Y has L and M. Rewrite X, insert L, insert M. You call M here. Then M doesn't contain any child. So LX will be rewrite. And then L will be called. However, L doesn't have a child based on our depth limit too. So basically, you just call L, then X will remain. Then if you call X, A and B will be inserted. So A and B will be inserted, and so on and so forth. So basically, you will be able to traverse all the nodes here. However, there is no goal node. So you won't reach any solution here. Yeah. So that's the disadvantage of depth limited search. In case you have selected your depth limit, which is here, an example is 2. And uh, however, the depth limit 2 doesn't contain any goal node. So basically, we won't look or we won't find another solution or we won't find our solution for this one. So thank you guys for listening and we'll move to our next algorithm.